Hello, hi everyone, welcome back to the channel. So today in this video lecture, we'll be solving this problem, sum of two integers. So we are solving the blind 75 list. So blind 75 list covers the most important patterns which are very useful for the coding interviews. So in this section, which is this binary section, we'll be solving problem related to bit manipulation. So this problem is one of those category of problems. So you can expect bit manipulation involved in the solutions of these problems, in the optimal solutions of these problems. So this is going to give you an idea. Before you jump to the final solution, try to think of the solution by yourself, how you can use the bitwise operators to get to the solution. So let's first read the problem statement. The problem statement is simple. We're given two integers a and b, and we have to return the two integers, sum of two integers, but without using plus and minus. Fine. The range of integers is -1000 to +1000. So let's see how we can do that. So we're given a and b. They are integers. We want to add a and b, but we cannot use plus and minus. So one of the naive solution which may come to the mind is simply increment a or change a by b times. So let's say a is 5, b is 4, then what I can do, the sum of these two is 5 plus 4, that is 9. But without using plus, what I can do is I can increment this 5 by 4 times. So 5 incremented by 4 times becomes 6, then becomes 7, then becomes 8, then becomes 9. So that will give me my answer. Fine. But let's say, since we are given that the range of integers is from -1000 to the +1000, so let's say b is -4 and a is 5. So 5 has to be decremented 4 times. 5 becomes 4, then it becomes 3, then it becomes 2, then it becomes 1. So 1 is the answer when I add a and this b, and that's true. So I get a solution which runs in big of b time complexity, where I just have to iterate over a. So iterate from 1 till b I plus plus if b is positive, so a plus plus if b is positive. Otherwise, if b is negative, then iterate b times again and just decrement a. Fine. So this is the case when b is positive. This is the case when b is negative. And that's all. This is going to give me my answer. The complexity is big of b. The time complexity, while the space complexity is constant. But we have to get a solution which is of constant time complexity. So to get these type of solutions which are of constant time, we can think of bit manipulation. Fine. So we can think of bit manipulation if we have expected time complexity like this. So let's see how. Let's just see how. So let's start with the observations. Let's start with a. Let's say, let's take some two numbers, 0 1 0 1 0 0 1 0. So this is 5 and this is 2. So I want to add these. If I add these two numbers, I get 7. So what is the bitwise form of this 7? It is 0 1 0 1 1. So now try to relate these two numbers with this number. So I get a 1 when I have 1 and 0. I get a 1 when I have 0 and 1. I get a, okay, so is it okay, 1 1 8. So this is 7, this is not 7, okay, this is 7, 0 0 1 1 1. So I get a 1 when I have 1 0 0 1, I get 1 1 0, I get a 1. So this is 1 0 0, I get a 0. So this is not there. So this is 7, fine. Now observe how we are getting 7. When I have opposite bits, I get a 1. You can see that. When I have similar bits, I get a 0. Now, which operator supports these kind of functionalities? Think about XOR operator. How it works. When I have dissimilar bits, I'm gonna get 1. 1, 0, I'm gonna get 1. When I have similar bits, I'm gonna get 0. 0, 0, I'll get 0. Is it the case that sum of these two integers is just XOR of these two integers? Yes, this is the case for this particular example. Let's say if this solution holds for all other cases. Let's take one more example, 0, 1, 1, 0, 0, 1, 0, 1. So this is 6 and this is 5. 6 plus 5 is 11. So I must get 11 if I XOR these two numbers. 0 XOR 1 is 1, 1 XOR 0 is 1, 1 XOR 1 is 0, 0 XOR 0 is 0. But, and this number is 3. But the answer must be 11. That means there is a problem. There is a problem with the observation, with the solution. This is not a complete solution. We have a problem. So how this 3 is different from 11? Let's write 11 in its bitwise form. So 11 can be written like this: 8, 0, 4, 8, 4, 2, 1. Okay, 8 plus 3 is 11. So this is 11. How this 11 is different from this 3? This is different at this position. We have a 0 here, we have a 1 here. How it is, how, so what does that mean? What does that mean? That means when I have 1 below 1, I just cannot put 0 as it is. I have to do something else. What I have to do is, I have to pass a carry. So when I XOR 1 with 1, I have to pass a carry to the position just left of it. Now I get a carry. So this carry has to be involved in the resulted number at this position. Fine? Because this carry, when I XOR this carry with the XOR of these two numbers, like 1 XOR 0 XOR 0, I'll get 1. And that is going to give me my answer. This is the observation. Fine? So how we'll handle it? So let's take an example. Let's take a more generic example. Let's say we have 0, 1, 0, 1, 0, and here we have 0, 0, no, 0, 0, 0, 1, 1, 1, let's say 1. So this is 10 and this is 50. Now let's follow the solution. Let's apply the intuition that we have till now. 0 XOR 1 is 1, 1 XOR 1 is 0, but I need to pass a carry. Let's pass a carry to the left position. So I have 1 here. So 0 XOR 1 is going to give me 1, and now 1 XOR 1 is again going to give me 0. But since I am XORing 1 with 1, I have to pass a carry from here as well. So I pass a carry to the left position. So here 1 XOR 1 will give me 0. Now this 0 XOR the carry which I'm getting from the right position will give me what? It is going to give me 1. So I'll get 1 here. And here I will have 0. Okay, is it okay? Yes, I get a carry. Then okay, so 1 XOR 1 will give me 0, and then I have to pass a carry, right? I have to pass a carry to the right position, to the left position. So 1 XOR 1 is 0, and that 0 XOR 1, this is the carry which I am getting from this position, is going to give me 1. So that's why I'm putting 1 here. Now I'm also passing a carry to the right position, that will have 0 XOR 0, 0 XOR 0 will give me 0, but 0 XOR 1, which is the carry which I'm getting from the right position, is going to give me 1. So this number is 16 plus 8, that is 24, plus 1, that is 25, and that's my answer. Fine. So you got what we have to do here. We have to XOR these two numbers. So this is the first step. So we have A and B. There's no doubt we have to XOR them. So we XOR them. So when I XOR these two numbers, what I will get 1 0 1 0 0. But this is not the complete answer. I have to change it a little bit. I have to handle the carries. Where I have to handle the carries? Here, then here, then here. So how will I handle these carries? When I get 1 below 1, I have to pass a carry towards the left position. When I get 0 and 1 or 0 and 0, I do not have to pass any carry towards the left position. So this is the only case when I have to get a carry as the resultant. Which bitwise operator can do this job? Think about it. It's the AND operator, because 1 and 1 is 1, 1 and 0 is 0. So this is the expected thing. This is the thing which we require. When I AND 1 with 1, I get 1. That means, what does that mean? That means I also have to AND these two numbers to get the carries. But not only ANDing will be sufficient, but like just ANDing these two numbers will not be sufficient, because the carry has to be passed to the position just left of the position where the carry is generated. Like the carry was generated here, then it has to be passed towards left. Then the carry generated here has to be passed to the left. Carry generated here has to be passed to the left. How are we going to do that? That can be done using left shift operator. So let's AND these two numbers. So when I AND these two numbers, I get 0 1 0 1 0. Now the carry generated here has to be passed here. The carry generated here has to be passed here. The carry generated here has to be passed here. That means I must get a 1 at this position. I must get a 1 at this position. Fine. Okay. Why? Because the carry was generated here, 1 XOR 1 0, so I get a 0. But a carry passed here. So 1 XOR, so 0 XOR 1 is 1, but 1, so that's why I got a 1 here. But 1 XOR 1 and 1 will give me a carry, and that has to be passed here. And that is possible, this thing is possible only when I simply left shift this number. So perform a left shift operation over this number. I will get 1 0 1 0 1. I get this number. So how I can get the final answer using these two numbers? So this is the XOR of these two numbers, A XOR B. This is A and B left shifted by 1. Now let's XOR these two numbers. So this number and this number, let's XOR them. Why we have to XOR them? Because observe that the carry which I passed from here to this position, from here to here, has to be XORed with the resultant number, has to be XORed with the resultant XOR of these two numbers. So 0 XOR 1 is 1, and the carry will be XORed with this one. And that is only possible when I XOR these two numbers. Let's XOR them. 1 XOR 1 will give me 0. This will give me 0. Okay, so I don't have 0 here. I don't have 1 here. I have 0 here. So this number left shifted by 1 is going to give me this number. So 1 XOR 0 will give me 1. So let's use another color. 1 0 XOR 0 will give me 0. 1 XOR 1 will give me 0. This or this will give me 0. 0 XOR 1 will give me 1. But again, I also have to AND these two numbers, because observe that a carry is again generated here. When I XOR this one with this one, a carry is generated. So let's AND these two numbers again. 1 and 1 is 1 and 0 will give me 0. 1 0 and 0 will give me 0. 1 and 1 will give me 1. But 1 and 1 will give me 1, then 0 and 0 will give me 0 and 1 will give me 0 and 0 will give me 0. 0 and 1 will give me 1 or will give me 0. And now left shift this number by 1, because the carry generated here has to be passed to the left position. So when I left shift this, perform this entire operation, I'm going to get 0 1 0 0 0. So now I have this number, and this number. Again repeat the process. XOR these two numbers. 1 XOR 0 1, 0 XOR 0 0, 0 XOR 0 0, 0 XOR 1 1, 1 XOR 0 is 1. Now here we can see that we will not generate any carry, because we do not get any 1 below 1. We simply get opposite bits. Okay, so how will we find it that we have to stop here? Since we are not generating any carry, we do not handle it. Since we do not handle any carry, we get the final answer. So how we'll figure it out? Let's find the end of these two numbers. 1 and 0 0, 0 and 0 0, 0 and 0 0, 0 and 1 0, 1 and 0 0. That means the end of A and B is going to give me 0, and I have to stop here. This is my final answer, and we can see that this is indeed 25. So I hope you got the process, what we have to do. We have A and B initially, perform A XOR B, and this is my new A. Also store A and B, left shift 1 in some other variable, let's say C, because this is going to be the next second integer when I perform the iteration again. Finally the B becomes this C. Why? Because when I iterate again, I will again AND this A with B, I will again XOR this A with B, and I will continue this till this B goes 0. Fine. So that's all. That's the solution. So let's just code it. So let's use this while loop. While B is not equals to 0, use a temporary variable. We will be storing A and B, left shift 1. Then A will be A XOR B, and then B will become this C. Finally, this A will hold the final answer. So return A right from the end of this function. So that's all. Let's try to submit it. Okay, so it got accepted. So we can, let's discuss the time complexity for the solution. Now we can see that this can be continued till all of the numbers, till I just till I get this b to be 0. And the worst we can have is we have to iterate 32 times, because the integers are of 32 bits. You can see that. The worst we can do is we shift bits to the left 32 times. This is the worst scenario we can have. So in that case, we have to iterate for 32 times, but we already know the upper bound, a real value, that is 32 times. We will never go beyond 32, 33 like this. So in that case, the time complexity is constant. The iterations, the number of iterations will not change as according to the input size. So that's all for this video. If you like the video, then hit the like button and make sure to subscribe to the channel, and uh, continue in this series where I will be explaining the solutions to the blind 75 list, which are most important problems for interviews.